Okay, cool. So we'll get started. So the thing I want to share with you today is, I think it's actually in some ways similar to kind of what Paul was showing. It's one of the things that like kind of drew me to Pulumi to begin with, and something I think that's really, really cool. And let me kind of give you background on myself. So one, I'm kind of a lazy person, right? So like activation energy to go do something. Like I want to feel like, oh man, I'm going to be able to get something off the ground quickly and sort of get in that feedback loop. Like, yeah, things are getting better and better and better. Another thing is I spent, before coming to Pulumi, I spent a long time building and designing APIs as part of the .NET Framework team. So I sort of really buy into this idea of like abstraction is the way to like hide complexity, have experts be able to like say, these are the hard problems, you're not gonna have to think about them, and put a nicer interface on top of things. So I guess the other thing that I kind of like about me is I don't like confrontation too much, right? And so I'm gonna talk a little bit about this thing that I have built over the course of working here as like a side project that sort of helps solve all those problems. So I'll give you the sort of problem that I was trying to solve here, and this was, we have this open source project. In the root of every repository, we have these changelog.md files, and the expectation is like, when people are making changes to our code, they're putting something in the changelog.md that says like, what happened, right? So when new releases come out, people can like look at the list of changes and go, okay, I understand what's going on. So the problem there is that for a very long time we did not do that, right? And so we got sort of in the habit of never doing that, right? And so we introduced these changelog.mds, and for a long time what actually ended up happening is anytime we were going to go do a release, I would sit there and like look at git log and try to like write the GitHub changelog entry for all these things, and I would like walk around to people and be like, I don't understand your commit message, tell me what to do, like give me the 2-sentence summary. And I didn't like doing that, right? And so then what we decided to do is like, we're gonna write on a wiki, thou must edit changelog.md before checking things in, right? But again, like, that's easy to miss, right? Like you've got this pull request, it's got a bunch of these like really meaty things that you want to review. It's very easy to see, oh, they forgot to edit changelog.md, right? So it's like, okay, well now my job is like, I'm gonna just monitor every pull request, and when I see changelog.md isn't there, I'm gonna like type a shame message, like please go edit changelog.md, this is important. So that doesn't work great for two reasons. One reason is that like I don't like conflict, and so like I hate being the guy that's just constantly hitting you with the stick. And then the other thing is like now I have to take interrupts every time PRs are open to like make sure the right thing, right? And so what I wanted to do is like solve this problem. I want to automate this problem away from me. And in theory, GitHub should make this very easy, right? So GitHub has this like very rich webhook interface where you can ask GitHub to send you information when events happen, and then you can go take action on those events, right? These very simple event-driven applications. When I originally started this, it's like, okay, I want to use GitHub Webhooks. So what do I need to do to get GitHub Webhooks working? Well, I need an HTTP endpoint somewhere that I can put code in, right? And it's like, okay, now I'm kind of stuck again, right? Because as a guy who is coming to Pulumi from this .NET world where you're writing console applications all day, right? Like booting a web server in the internet, publicly accessible, getting an endpoint, getting my code there, like it's actually a lot of work, a lot of activation energy, right? And so what I did was, for a while, just didn't do it, right? And so finally I get to the point where it's like, no, I need to come up with a solution here. And one of the things that I try to do is like, well, let me write down the code that I would love to write. And then let's figure out like how we can actually implement that abstraction, right? And so what I thought is like, okay, GitHub Webhooks, like there's a lot going on, right? Like GitHub, you need this HTTP endpoint, and GitHub's going to send you a message. That message is specially formatted, and you have to validate that message is coming from GitHub. And the way you do that is you give them this shared secret, so you can like do a hash to ensure like, oh yes, it actually is a valid message coming from GitHub. That's a bunch of code. I probably don't want to write that every time I'm making a GitHub webhook. I want a really cheap way to build these webhooks, to build these bots, so I can do the automation and then get back to the things that I enjoy, right? And so I thought, okay, well, what would it mean if I wrote this like new GitHub webhook, right? And this is a Pulumi component, so what would this Pulumi component look like, right? Well, like all Pulumi components, I have to have a little name here, and so this name here is changelog status check, right? So I'm going to use this GitHub webhook to deal with changelog messages, right? Well, then what are the other things I would really want to do? Well, I have to tell it what repositories I want to listen to, right? So in this case, I'm saying, oh, I want to listen to this Scratch repository that I have on GitHub, which is what I was kind of using for testing, right? And then what are all of the different events that I want to listen to? Well, the thing that I care about here is just pull request, right? But GitHub has tons of different events, and I could listen to some of them. I might want to listen for when an issue is labeled and take action on that, or when a member is added to a team and take action on that, right? All these little things. For this one, I cared about pull requests, right? And now what I want to do is I want to just like write the code that takes action on that event and does something, right? So here I have my code that kind of does the action. And that's all I want to write, right? I don't want to think about anything else, right? I don't even want to think about like, oh, once I spin that code up, it's got this HTTP endpoint, and I'm going to go to github.com, and I'm going to like go to my repository, to the webhooks page, and like type that thing in, generate a secret, put the secret in here so I can do that validation and everything. I don't want to think about any of that stuff. This is the code that I want to write. And you may not be surprised to learn that like I actually can write this code because it's here, and it like actually works, right? And so I want to now show you a little bit about what the code ends up doing when you deploy it with Pulumi. So we'll jump into the terminal here. And so we will do Pulumi. So first things we'll do is so that you know there's no man behind the machine. I'll go to my LSMG Scratch repository, go into settings, and if we look here in webhooks, it says there are no webhooks, right? Add webhook, and I don't want to click this button because it's like if I click this thing, it's like, man, here's a bunch of stuff I don't have, right? And I don't want to really think about it. So I'm not going to click that button, right? I'm going to just
stay away from the button.
Yeah, exactly. Stay away from the button. This should be like this is a tagline of like infrastructure as code, right? It's like stay away from the button. Don't ever hit it, right? Or hit it once to figure out what it did, and then like code it up and never hit the button again, right? So yeah, so we'll do Pulumi update. So unlike Paul's example, which was like deploying a really bunch of heavyweight resources, this thing actually can go quite quickly. And so we're going to see first a little preview of what it's going to do, and we can see a little bit about the shape of what we're doing here, right? So I kind of said we need a couple things, right? Like we need this HTTP endpoint that has my code in it, and that's what this AWS API Gateway X API thing is, right? This is an abstraction that we've built that makes it really, really easy to have Lambda functions on AWS that are hooked up to API Gateway. Right? So you give me some code, I'll give you an HTTP endpoint, it's going to run your code. That's great. You can see underneath this abstraction is actually managing the lifetime, or the life of a bunch of different AWS resources, right? So we have a permission for the Lambda. We have the API Gateway stage, which is a thing that like I kind of understand what it is, but I don't fully understand what it is. But fortunately for me, it's hidden behind this API thing, so I don't like really have to grok it at a fundamental level if I don't want to. We've got the roles and the role policy attachments. We've got the actual AWS function like that you think of, and the API gateway that ends up actually exposing it, give me that endpoint. So I mentioned too that we kind of like need a shared secret, right? Like we need this secret that's going to be in my code and it's going to be on GitHub. And so we've got this thing in here where we're going to create a random number. And so this random number is like when you create this resource, you get a random string, and then it never changes, right? So this is kind of like a way to generate a random number once in your program, but then remember that value for the lifetime of executions, right? And then the thing that I need to do is I need to like once I've got my API gateway, I've got that HTTP endpoint, I've got my secret number, then I need to go tell GitHub, hey, please register this webhook. I need to actually do that. And so that's what this GitHub REST hook thing is doing. It's modeling the ownership of that registration. It's modeling the life cycle of that hook that's registered in GitHub. And so okay, so I've got like 12 things here. I think I have 12 things to create. Like, that's great. Do I want to perform the update? Of course I do. I want to perform the update. So we'll hit enter, and it will be quite quickly, assuming the demo gods are at least not on steal or whatever. So while this is working, we can go back a little bit and see sort of like what the code I actually wrote did, right? So we can see here, like what is our handler going to do? Well, we have this handler gets in an event, right? And this event here is actually typed as GitHub Webhook request, so I can actually like dot into this event and like see interesting things on it. So do like event dot data ID type, right? This sort of stuff. So that's like one of the nice things about being able to define this like function in real code and have it live with the infrastructure behind it, like you get this very nice thing, right? So we're going to, we get this pull request, we've got some little helpers here. So one helper is this like log function that just prints some nice stuff to the console. The other function is this set status thing. And so this is what's actually going to put the GitHub status check that says like you either get the green check mark or you get the red X. It's like just like CI would have for you, right? And so we've got this little like status helper, so we can use it a couple times. You'll notice in here, the status helper is just using the normal Node.js GitHub API, right? So this is just like code that you would write in any sort of like Node.js app. If you wanted to implement the hook, you're able to do that in Pulumi, but you're able to do it in the same program that defines the infrastructure that backs this thing, which is like kind of cool. So then we just have a bunch of business logic that like lets us decide what we want to do, right? So for these events, like we actually get a bunch of information from GitHub on different things, and there are some events that, like some types of events that we don't actually care about, right? So we can ignore those and return from our handler. If this is a thing we actually care about, like this is an interesting pull request, right? Like we can try to see if the target branch has a changelog.md. Because if it doesn't have one, like we shouldn't tell you, please go update the changelog. There's nothing to go update, right? And so we have a little bit of logic here about looking in the target branch to see if there's a changelog.md, and if there's not, saying, oh, we're going to log. There's no changelog, so I'm going to skip it. These log messages will be interesting later because they're how you like debug what the heck is going on, right? Well, if it looks like we need to actually do this check, then we're going to set the status to pending, right? This is going to give you the yellow circle in GitHub. And then what we're going to say is, well, there's a class of issues probably where you don't need to put something in the changelog. Like it's uninteresting to put something in the changelog that like I made a change to CI or something. There's stuff that's checked in that they kind of don't care about. So we're going to provide a way to say, okay, if this impact/no changelog required label is on there, we're going to set the status to success. Otherwise, what we're going to basically just do is like get all of the files from the PR. We're going to look through them. If one of them is called changelog, we're going to say, okay, you've edited the changelog. That's great, success. Otherwise, failure. And then the last thing that we kind of so this here is all of the code that happens every time a pull request is open. Right. This is the business logic that runs every time a pull request is open. And the last thing that we have down here is this export statement that just lets us see what the URL that book was created. That's just helpful for like debugging stuff, right? So we kind of ran this thing, and you can see it eventually did create everything, and it gave me as an output this hook URL. And so if I went here, I would probably get a bad request because I'm not coming from GitHub or whatever. But we've done that. So if we now alt tab back to this webhooks thing and hit refresh, you can see, okay, now a webhook has been registered for a pull request. And it's got this thing, and that G0 thing sort of matches what's going on here. So now what I want to do is kind of show you it in action. Right? And so if we go into Scratch and do code, and then we're going to say this is a change. So we'll save that, and then we'll say git commit dash push. This is probably actually going to yell at me because I need to do a force push. Ellis. No. It's good that I cannot like push without screwing up. Okay, so we've pushed the code now to GitHub, and so we can go back into our repository. We can go into pull requests. We can do tells me that I've pushed this thing. Compare on pull request, and say create pull request. And so the pull request gets created. We see for a second it was saying, oh, everything was okay, and then it said, oh no, there's a status check, and that status check has failed. It says, please update changelog. Right? So it's pretty cool. Like now I have this thing that like helps me shame people, right? And I can go add this label because we had this policy like, oh, if I put this label in, kind of do stuff. So we'll attach the label, and then we give it a second, and status check runs, and then it should be green, I hope. Get there.
It might help you shape people, it helps enforce best practices across the community.
That is a much better way to say it, right? Okay, so this didn't work, and so I don't know. Yeah.
Can you refresh yourself?
Oh, can I refresh? Yeah, I can refresh. Maybe that will be it. Hey, okay, that's good. I mean, it's not a bug. It wasn't a bug on my end. It was on there. That's good. So just kind of want to show you two other things real quick. So first, I'm going to remove this label so that we kind of go red again. Okay, we went red again. That's great. So I kind of want to just show you too, like sort of the some of the things that I like about Pulumi for like the development experience, right? So one thing that I can do is I can run this Pulumi logs command, and you remember in that application I was calling this log thing that was in the wrong place. So in my application, right, I had those log messages and I was writing things to stand out. So those things get picked up by CloudWatch. Like CloudWatch just picks up console writes that your lambdas do, and Pulumi here, since it understands, here are the lambda functions that are in your thing, it can go query CloudWatch and say, please give me all the logs for all these things, right? And we can print it out. And so this is super helpful for debugging, right? Because I can add as many log statements as I want, and then I go take some action and run Pulumi logs again and do this sort of stuff. So the other thing that's kind of nice in the development experience, and here's where we have to be super careful because I have to type live code and I have to do it correctly. Those are always two very hard things. So one thing that we could do, right, is we could like say, hey, you know what? I'm mad. I wrote this bot. The bot should treat me special, right? I shouldn't have to update the change log, right? Like I'm a special guy. I wrote the bot. I should get that right. And so we can just like add some code in here, right? And we can do if pr pull request. I think it's user login. So then what we can do is we can log. Oh my goodness, I've got to restart to stains. I'm not going to do that right now. So I've made this little change, and now I want to deploy it, right? So I'm going to run Pulumi up. This is similar to what Paul did. So I'm going to run this, and Pulumi's going to kind of go figure out what needs to change. And so certainly the code inside the lambda needs to change, and Pulumi will detect that and show me that, hey, it's going to go change that stuff. And then Pulumi is a conservative system, so it will say, hey, you know what, I'm not 100% sure that when I update that function, it's not going to like change something about the function that has to be sort of pushed downstream. So we can see here that like this update, which is conservative, says, well, I'm going to go update the function, and then this other stuff I'm going to update because maybe these values end up changing. But if we actually go ahead and do the update, when we say yes, it will sort of behave the way we want. It will just update the lambda function. So we'll run the update. That'll take a second or two. It says updated. Okay, great. And so we see like the hook URL didn't change. Because the hook URL didn't change, I didn't need to go change that relationship that I had with GitHub. And if we actually go back here, you can see that's true. So the webhook here is still the same. Right? And so now what we can do is we can go close this pull request. Why is it happening? This is refresh. Yes, Mike's strategy of always refreshes is good. So we'll say close pull request. And then we'll say reopen pull request so we get that event to happen again. And so what we should see is it should go green even though I haven't updated the pull request. And then if I come back here and I do Pulumi logs, it'll go get the logs from CloudWatch. So we can actually see one of the things it did was ignored the events of type close, and so we'll just do Pulumi logs -f so we follow. And actually now we do see the logs from that event. So we saw this as pending, and then we said, oh, it's Matt, I preview, and we set the stats to success, right? And so I really like this because I can, like, in 80 lines of code, I can like build this thing, which is like, right? And the reason that I can build that is I was able to use Pulumi's ability to generate, to build real abstractions to like do the hard thing once, which is like implement this GitHub webhook thing. And then now I just get to use it whenever I want. And the other thing that's really, really great is like if we actually look at this here, this GitHub webhook thing is actually coming from this NPM package at LSMG Pulumi GitHub Webhooks, right? So that's something that I have written, and then I can just consume it like any other package, any other new package, right? And so I think that like is pretty fantastic because it allows me to basically do something hard once and then get it in a reusable artifact that I can use for like the rest of my life and make all of my future problems easy. So that's kind of the thing that I like about Pulumi, and I think one of the things that kind of showcases, the ability to build these abstractions lets you sort of start to program the cloud, as we say, as opposed to just thinking of like, oh, I've got my infrastructure there to deploy and I've got my application system. So does anyone have any questions? Yeah.
So does your package abstract the creation of Lambda? And
yeah, so we can actually go to the code. I can show you this stuff. So how do I want to do this? I think I want to do this.
follow-up question: do you set it up as a string, the body of the Lambda, or do you zip it?
Yeah, so I'll actually that's a great question, and I'll actually show you the answer. So if I go into the GitHub Webhook Service thing, and this actually is available on GitHub. So there's just a repository called GitHub, or Pulumi GitHub Webhooks or something in LSMG. But we can talk a little bit about this, how this kind of works. So I think the first question was, do you abstract away, like do you abstract over the Lambda? And the answer is that, and I think that question is like, well, what if I didn't want the code to be in Lambda, which I would want to be in Amazon or Azure, functions or whatever. And so the answer is, I do not today, but like it's just code, so you could go do that, right? So today I actually do hard code in using this AWS X API Gateway API thing, which is yet another abstraction that like Pulumi has built and lives in the AWS package. But I could design this in a way where I would be able to like you would be able to flop that, right? Like if we saw what Paul had done, like you could imagine adding an R here that's like, target environment, Azure, or whatever, this sort of stuff. I don't do that today, but that's certainly something you could do. I think the other question was, do you upload like a string or a zip file for like sort of the body of the Lambda? And so I will say that that is something that's actually, when I'm using this abstraction, is handled for me, right? So you'll notice in this abstraction, the event handler for this slash, this post thing, is just, again, another JavaScript function, right? And so one of the cool things that Pulumi can do when you're writing Pulumi programs in JavaScript is it can take these like actual functions and serialize them, and then sort of rehydrate them in the cloud, right? And so what actually happens here is a lot of this function is doing those things I didn't want to have to do every time. So I'm checking the signature. If it's an event that's like a ping event, that's something GitHub sends every time you register a webhook. I'm just saying, well, I can respond to the ping event. I don't need to like call the user code to kind of go respond to that, right? So there's kind of all of this stuff in here that I don't have to want to write every time. This is common code that happens for every GitHub webhook. And then at the bottom, what I do is I just parse the body of the event, and then I call the handler that was passed into me, right? So this is the user code that's actually written. But when I give this whole thing to Pulumi, to API Gateway, what it's actually going to do is it's going to serialize that Lambda into text. It's going to find all of the things in node modules that you depended on, and it's going to zip all of that stuff up and like send that off to Amazon. But I don't have to really think about that. I just know, oh, I've got this AWS X API Gateway API thing that I can give a JavaScript function to, and it like gives me an HTTP endpoint in the cloud that like runs that code. Yep.
Same deal for that. I'm assuming hook.ts is how you actually register the webhook in GitHub.
Yep. Yeah. So hook.ts is like that, and so hook.ts is actually so hook.ts, and this is like the scariest code that exists. So I will say that this is not typical like Pulumi code. This is like 405, advanced topics in Pulumi level shenanigans that we're doing. But one of the things that you can do in Pulumi is you can implement your own resource provider, right? And so like if you have an object that you can model as like has a CRUD lifecycle, right? You can go write the implementation of create, update, read, delete. in Pulumi, and then now you can start to use that. So this GitHub Webhook provider stuff is basically built on top of that provider thing where I've like, here's how I'm going to do diff. When I need to go create, this is creating the actual webhook, right? I'm going to use the GitHub API, I'm going to authenticate to it, and then I'm going to like call create hook depending on if it's an organization or an owner, depending on kind of what comes in, right? But I am able to like do that in Pulumi, and I'm able to model this thing, which you may not think of as like a traditional cloud resource, as a resource because it does have these like CRUD semantics, right? And so I can build these providers that sort of like help me solve this problem, even if there isn't something built into the system today. So that was actually an excellent question.
The other useful thing for a dynamic resource provider is sometimes the cloud vendors will actually launch functions on their cloud without support either in their template language or in providers itself. And as long as there's some API, you can create your own dynamic resource for those, so you don't have to wait for Terraform driver or wait for CloudFormation or ARM support or whatever. You can start programming right away.
Yeah, this is one of the things we've seen with some of our customers who are like using Azure. Like Azure will add new services, or there'll be certain knobs on existing services that aren't exposed through the existing Terraform provider, and because of that, they're not exposed through Pulumi today. But you can use this dynamic resource to go actually flip those knobs in this very controlled way. It's like lifecycle driven way. So yeah, that's kind of how that works. Yes.
Just kind of going back to this guy's question,
Yep.
just like more broadly though, I'd love to hear anyone's opinion on it, is that like one of the kind of implicit promises of Terraform was that you could be cloud agnostic.
Yep.
Do you see that? But I feel like a lot of people have kind of given up on that.
Sure.
Because they lock in AWS
Yep.
or Azure.
Yep.
Do you think that's more feasible with Terraform or Pulumi? Or
So-
is that just not helpful anymore?
So I think there's two things to unpack there. One is like a technical thing of like, can you design an abstraction that is like cross-cloud, right? And I think the answer to that is like, yes. But what it means is you end up targeting kind of the lowest common denominator. Everything is there. And we've actually, one of the things we have built in the past is this Pulumi cloud package, which was like kind of trying to be this. So we had this concept of cloud.function, right? And when you were targeting AWS, that means you're going to do a Lambda. When you're targeting Azure, you're going to do an Azure function, like this sort of thing. We had similar sort of abstractions in there for like running services and tasks, so things that would create, ECS services or whatever Azure Compute.
ACI.
Yeah, ACI, yeah, Azure Container Instances, that sort of stuff. Like we had those things. What we found is people who are coming to us are like, they're always like, yeah, I want to be cost proud. I want the agility, right? And then it's like, okay, well, you don't get to fiddle with all these knobs, right? And they're like, oh no, I don't. I think I actually do want to fiddle with that knob, right? Like I'm willing to tie myself to AWS and fiddle with that knob. So you can build the abstractions. I think it's still an open question as to like, will they come, right? And like, will people actually use them? But I feel like it is easier in Pulumi to build this stuff in Terraform, because for these things where you actually want like, very rich decisions, you're like, if I'm targeting AWS, the shape of my resource graph has to look like this. If I'm targeting Azure, it has to look like this other thing, right? Like it feels much more natural to me to write that sort of complex logic in a real programming language instead of something like HCL or YAML or Cloudflare. These sort of DSLs for sort of describing resources. Like at some point, like when you're building these powerful abstractions, you need like powerful tools at your disposal to build them. And so I think they are easier to build with Pulumi. The hard part is basically building them in a way that is like palatable to end users, instead of saying, because what we have found personally is that like end users say, oh, but I still want to control the knobs, right? And like once you say I'm going to control the knobs, like yeah, I can give you an abstraction, but like that's cross cloud. But when you start, fiddling those knobs, it's not going to be easy to move from AWS to Azure.
Two other things on that. Like one, actually, it's interesting is this particular example that Matt had is actually kind of wonderful because it didn't mention AWS at all in the actual user page.
Yeah.
So there was no mention of AWS in anything. So it could have been, he could have gone and implemented Azure support for the exact same API, and users of it could write the exact same code, and then suddenly that code starts running on Azure the next day when they send it new stuff. Right? And so that was a particular example where it didn't depend on anything specific. I guess the other piece is like, I think we have that experience with that cloud library where it was good, but people tend to want to like fiddle a switch that wasn't available in lowest common denominator. One of the things we have found though is a lot of users of Pulumi are themselves building their own sort of abstractions, which hide away just the stuff that they want to hide away. Right? And so it's hard to build a general purpose layer, but individual users often can define, hey, here's the abstraction that makes sense for my kind of business use case that hides away as much of the complexity as I can, but still gives me access to the stuff that I want to take some vendor lock-in over here because I want to use that thing, but I know that now when I move to Azure, or when my boss comes to my door and says, hey, we're moving to Azure, like I at least don't have to rewrite everything, I only have to rewrite 20% of my code. And so we've definitely seen that idea of wanting to be able to build abstractions as a tool to manage the risk of multi-cloud generally as something that a lot of folks are really trying or doing in practice.
Anybody else?
So I saw you run Pulumi up
Yep.
there. When I'm pushing code to production, I want to test it out first
Sure.
and stuff like that. How do most customers handle this kind of scenario? Do they run that against their test environment and then check it in?
Yeah, so I think there's kind of two ways to do it. So one thing, Pulumi actually makes it really easy to. This kind of talks in a thing Paul had glossed over in his thing, but he had mentioned this thing about auto-naming, right? Which is like when we create these physical resources, by default, Pulumi takes that. They're usually named by like what that first string parameter was, but it appends a bit of entropy there, right? And so what that allows you to do for a lot of stuff is basically spin up independent copies of your program, right? And so one thing that you can do is when you want to test it is like you can say, oh, I just want a private version of this, right? So I do Pulumi, I do Pulumi stack init, migrate dev stack or whatever, Pulumi up, deploys the whole thing there. Our service actually, the infrastructure behind it is written in Pulumi, and that's what a bunch of our service developers actually do. They spin up their own private copy of the infrastructure, and they get like everything, soup to nuts. They get the ECS cluster, they get their own private RDS database, like all of this stuff, right? And they can start iterating on that. The other thing that some folks do is, again, they have like a shared thing, right? Like you'll do a GitHub PR into like a branch, and then you'll do extra testing sort of after that, or as part of the PR, you'll maybe go check out an environment and go update it, right? And so you get to kind of choose there. The one thing that I think Pulumi makes very easy is because by default we kind of push you through this auto-naming into creating infrastructure that can be multi-instance. It ends up being easier to get these ephemeral environments to start doing things.
Because in general, like infrastructure is code in there, and I think some of the Matt said take that even further in Pulumi than in some traditional infrastructures go, but like there's this really freeing aspect of once you've like really got infrastructure as code in place with Pulumi or with some other tools, that like it is easy to stand up in their environment, it is easy to do some ephemeral testing of that environment. Like you don't have to worry about, oh, I've got this one special environment where I can do validation and maybe it's slightly different than my production environment, but I'm just gonna hope that it's you can really like take something that looks just like whatever your production scope is, recreate that, do some validation against it, tear it down. And so we do a lot of that when we see our users doing a lot of that kind of stuff with it.
Yeah.
Slightly silly question. Can you put Pulumi into the webhook so that every time you do pull request, it creates infrastructure or something like that?
Yeah. So
Can you bypass the Pulumi app somehow?
Can you bypass Pulumi up? The answer to that is no. So what you would do is like you could definitely in the webhook like boot a container instance that goes and runs Pulumi up, and you could maybe take some from like you could imagine designing a system that like has a control plane that does some resting and you poke events to it, and behind the scenes it boots Pulumi and goes and does stuff. We've got some folks that kind of want to use Pulumi for that, and we're sort of like exploring that use case. I'll say like today it is like not as it's not as great an experience as we would want it to be, and so that is definitely something like we're thinking about. How are we able to take like the Pulumi technology and move it from a tool that is like generally run by an operator in a terminal or run in a CI setting, and much more into like this embeddable sort of library that allows you to like do desired state management of infrastructure in a sort of library way instead of tied to a tool with like a specific workflow. So yeah, today it's shell out to Pulumi. Hopefully tomorrow will be like, oh, we've got these APIs for you. You can just go use them in your Express apps or whatever you want to do. Anybody else? Okay. Well, thank you so much for coming and listening to me explain what makes me happy about Pulumi. Hopefully it makes you a little happy about Pulumi too.